This is for especially lecture. All right, so now I'm just going to start the review session for this course SCI 154, and all section inshallah they will listen to me. So you should know this one in chapter 4.1 about the aqueous solution. Aqueous means, you know, that different type of questions you can, a chemical equation you write, wherever the word aqueous is coming, aqueous means what? Aqueous means water. Aqueous means water. It means that the reaction is reaction plus water, then you will get the product aqueous, AQ. Whenever you see AQ, it means that the reaction is carried out in water medium. So the solution is there. Solution means the reactant plus the product you have. The solution contains two parts, solute and solvent. The solute always is small amount, small, and the solvent is the big amount. So in this way you should know that. Suppose an example we have Pepsi Cola, right? Pepsi or Sprite. In this Pepsi or Sprite, which one is the solute and which
دكتور no sound.
طلع مو موجود.
الشبكة عندها تقطع ريكونكتد. طالع اللي عندنا يحاول عدة الاتصال.
الساعة 10 وللحين ما بدينا.
Excuse me, you listen to me or not?
Yes.
Now we listen.
Okay. All right. In this chapter now, strong electrolyte, weak electrolyte. You should know the example. All strong acid are strong electrolyte. Strong acid, strong electrolyte. Weak acid or base. Sorry, weak acid or base. Weak electrolyte. And non-electrolyte, only one example, that is glucose. That is non-electrolyte, C6H12O6. Why it is non-electrolyte? Why the difference between weak electrolyte and strong electrolyte? So here, strong electrolyte, suppose strong acid we have. So it has 100% dissociation of the ions plus Cl minus, right? Because of this ion, H plus and Cl minus, this you will get electrolyte. In the weak acid, H2CO3, this is an example. So you will get H plus plus CO3 2 minus. This is weak acid. Only 99% it will go back and 1% dissociation only. In the first case, 100% dissociate into ions. So that's why you will get a strong electrolyte. Why it is weak electrolyte? Because these ions are not completely present in water solution. Only 1% ion present, only for weak acid. Non-electrolyte is that one in which there is no ion, no plus and no minus, nothing, no ions. Glucose doesn't have any ion. So this type of electrolytes you have. So, and now there is another question. Suppose you have a solution, different solution. I will write here. For the precipitation, right? For precipitation, suppose you will have barium chloride plus sodium sulfate. Suppose you have. So the question may be asked, okay, which compound is solid, you will get it. So which solid compound is possible? So you should know that the solubility rule I already explained in the chapter. Solubility rules, only the second group they will react with any non-metal, you will get solid product. And the first group, and again I will write here. Okay, group 1 or NO3 or NH4 plus. These, wherever you found these all three in any group, in any compound that is soluble in water, no solid. Alright, now if you have group 2 or transition metal, the transition metal I already told you, the lead, silver, gold, mercury, zinc. These are transition metal which I told you in the class. Just memorize this only. If they are present in the compound, just like we have silver chloride plus sodium sulfide, so you will get silver sulfide plus NaCl. So now silver sulfide is formed here. This is solid. This you memorize this thing. So no need to memorize, just only lead, silver, Au, mercury. If you found this one in any compound, then you can say, sir, this compound is solid formation. Any question now which is not clear? Any question please which is not clear?
The section is clear.
Doctor, what is the last element? ZW?
What we need
Zinc,
to memorize.
Zn.
Okay.
That's mean if there is any solid, I didn't deal with it. I didn't do anything with that.
Yeah.
That's right.
Yes. If you find any, the question is which solid product are possible. So that solid product you will see either it should be the metal should belong to group 2 or belongs to transition metal, only these 5, no others. Then you can say, sir, this will give you solid product that will react with any non-metal, that you will get solid product. Otherwise the group 1 nitrate or ammonium, whenever they react, if you are getting product with this, that you can say it is soluble in water, it's not solid. Is it clear? All right. Group 2 with transition metal, solid, not soluble. Listen my lecture, please. Focus my wording. Solid, not soluble. Soluble means clear solution, you get it. If you do this type of mistake, I'm sure you will not do the quiz properly. If you will not listen my lecture properly. solid or precipitate, you will get with group 2 and transition metal. Soluble or clear solution you will get from group 1 or nitrate or ammonium. These are the three things which give you soluble product, means in water is soluble. Okay, and these are the electrolytes. Then solution 4.4 is the molarity. You should know the formula of molarity. Molarity, capital M, the moles per liter, right? You should know this formula. So sometimes the gram is giving, and gram is not in the formula, so gram changed to moles. And you know this formula I always told you, mass over molar mass. If you have mass, write down here, molar mass you will get from periodic table. Then you calculate moles, alright. Then you will put this mole into this formula, this mole here, and liter, suppose you have 0.5 or 250 milliliter it is giving. So you divide change into liter divided by 1000. So you will change into liter because this liter is asking. So in this way you can calculate molarity. Any question please?
Doctor, can you solve a question? It's become more clear.
Okay. All right. Now suppose you have 2 gram of sodium chloride dissolved in 250 milliliter of water. What will be molarity? Okay, this is a question now. So molarity, first you write the formula moles per liter. अब there is no mole here. So what you do? The gram change to moles. 2 gram of NaCl, you should know the molar mass of NaCl, divided by 50, 30, 23 plus 35, 23 plus 35.5. So now this is 8 and 58.5. Then you will get moles here. This is moles here, you calculate. This mole you put into formula. Molarity is equal to moles per and liter. And now how much milliliter you have? 250 ml. This volume 250 ml change into liter divided by 1000. Change into liter, you will get 0.250. So you put here mole divided by 0.250, then you calculate molarity. Is it clear now?
Yes, clear, Doctor. Yes.
Doctor, I have a question.
Yes.
Milliliter always change to liter, right?
Yes, because you have to follow the definition of molarity. What is that? Definition of molarity.
Mole over liter of volume.
Your pardon? What is the definition
Mole.
of molarity? Formula.
Mole divided by solution L.
Liter of solution. Liter. So
Yes.
mole you will get convert mass to mole, and liter you will get milliliter change to liter.
Okay.
So,
Yes.
about the first questions, you didn't complete it about percentage.
Anybody who tell me how you calculate the percentage? Anybody please explain?
We take this the liter amount divided by the whole mass, molar mass, multiplied by 100.
Yes. Divided by the whole molar mass and multiply by 100. 100.
Yes.
Okay, clear.
Okay. So now, as I told you, two different compounds it is giving here, just like I already explained you here. Barium chloride, ammonium sulfate, sodium chloride. So suppose this three different compound is giving, right? And just you tell me what supposed to be solid compound is possible here.
It's PaCl.
Yeah, BHPL is not a compound. This is not a solid. It is a liquid, aqueous. This is also aqueous. Aqueous means soluble in water. When they mix, then mix, what will be the product you get here? The solid product.
Yes.
Either this barium react with sulfate, right? Or barium react with chloride. So chloride no need because it's already chloride. Okay. So your main compound you will get barium sulfate. This is your solid compound. Others all are soluble. All right. You see, number one, I told you. Whenever the aqueous is written in front of the compound, that is soluble in water. Right? If solid is written there, it means that is solid. If not, then you find out which one is group 2 and which metal is metal is transition metal and react with non-metal. Yes. Yes. Any question?
But doctor,
Yes.
will I be given what do you call them?
Yes. Yes. Yes.
Will I be given the result compound?
No, sometimes this resulting compounds will be given, and which one is solid you have to identify. Suppose this is not written
Okay.
here. Suppose this is not written here, and now different compounds we have written here. So which one is solid? You should know that. Sometimes these are not giving. You have to decide yourself which one is solid compound. Or suppose I will write here. I will write here. I will write here ammonium compound, ammonium chloride is solid. So my question is it true or false? Is it true or false? Tell me now. If suppose I write here in this question, ammonium chloride is solid.
False.
False, my teacher.
False.
Ammonium is
Right.
liquid.
So it is false because ammonium, whenever ammonium is there, is automatically soluble. So that cannot be possible as a solid. So this type of question you will see in the okay now chapter 4.4. Chapter 4.4 you also have.
Doctor, I have a question
Yes.
about table 4.1, which give us the compounds about the strong and weak electrolyte. It has about 20 compounds. Should I memorize it all?
Sir, I already gave you now 5 metal only to get that solid compound. You don't understand.
No, I mean the electrolyte.
Solid you should know that which one is solid acid or solid strong acid and strong base, weak acid, weak base. I already gave you the example. Strong acid H2SO4, HCl, hydrophosphoric acid. These are the, and chloroacetic acid. These are only 4 or 5 I told you. These are the strong acid. Strong base, sodium hydroxide, potassium hydroxide, calcium hydroxide. These are strong base. Weak acid, acetic acid, carbonic acid, and fluoric acid. These are 3 weak acid. This I already give the example in chapter, but you did not write it.
Well, I am with Dr. Ali, so I don't know.
Oh, this is a problem. Okay, now chapter 4.4 is oxidation reduction, right? What is oxidation? What is reduction?
Oxidation release electron or lose electron.
Loss electron.
Removal of electron. Removal of electron. Second, gain of electron, right? These are the definition. Oxidation reduction. Okay, now another definition is oxidizing agent and reducing agent. So oxidizing agent is this one. This one is oxidizing agent because opposite. And reducing agent is this one, opposite. Which is oxidation? It means that will act as a reducing agent. Which is reduction? This will act as a oxidizing agent. Okay, now suppose you have magnesium solid plus chromium sulfate you have, or copper, you will write copper sulfate. Now you will get magnesium sulfate solid plus copper solid also here. But magnesium sulfate is not solid. This can be solid, of course, because this second group. Anyway, now question is oxidation reduction. So you know that how to identify whether reaction is oxidation or reduction. What formula you will use? What the concept you have?
So
First of all, you should know oxidation of all the element 0. Oxidation of all element 0. 0. And oxidation of the compound murakkab. Compound murakkab. You will get different oxidation number. Alright. So this is murakkab now. This is compound. But here magnesium is pure metal. So its oxidation number is 0 here. But here magnesium sulfate, it is 2 plus and now this is 2 minus. You know that. But copper is pure element, so this is 0 oxidation number. But here copper is 2 plus and this is 2 minus. So now magnesium from 0 to 2 plus is increase or decrease?
Increase.
And copper increase.
Increase,
So from,
doctor.
huh?
The increase.
Copper 2 plus to 0 is decrease, right? So you know that oxidation number increase, that is oxidation. Oxidation number decrease, that is reduction. So in this way, you will find half oxidation, half reduction. So between oxidation, magnesium changed to magnesium sulfate. This is oxidation, and copper sulfate changed to copper. This is reduction. So in this way, two reaction you can write half oxidation, half reduction. Any question, please ask me now. No question? Determine oxidation number. Oxidation number of, suppose MnO2 minus you have. Another one you have H3PO4, suppose you have. So you have to determine the oxidation number of phosphorus, here oxidation number of manganese. How you determine? You know that idea?
Yes. First one,
Is it 3 or
MnO2. We write equation x plus 2 plus 1.
X plus 2. What about oxygen oxidation number?
-2?
-2. So you have to multiply -2 here. And equal to, don't put 0. You have to put -1 here. Whatever on the chart. If there is no
-1.
charge, you will put 0. So now x minus 4 equal to -1. So x equal to 4 minus 1. So you will get plus 3. Clear? Now do this one. Other
Please
students,
repeat that, please, Doctor.
sir, Mn is, if you consider, is x. Okay. X plus oxygen, how many atom? 2 atoms. So put 2 here. Multiply oxidation number of oxygen -2 equal to -1. Whatever the charge you have on the oxygen, this charge you will put here -1. Then you solve it. This simple calculation. X value how much?
Doctor,
Clear?
oxygen is 4 atoms.
So now total is 2 to multiply by 2. So -4. -4 is equal to -1. So x is equal to 4 minus 1. So become 3 plus.
Yeah, I know, but the oxygen we have 4 atoms, but divided by -2, go to -8, right?
Why divided by -2? Why?
No. We have 4 atoms of oxygen.
No, 2
So it
atom of
is.
oxygen, not 4. 2 atom of oxygen. Why 4?
Ah, okay. Yeah. I thought you were saying the uh, phosphoric acid.
Phosphoric is different. Now phosphoric you calculate. How many hydrogen atom? 3. So you put 3 here. What is oxidation number of hydrogen?
+1.
Plus 1.
Plus one.
Plus X. Plus 4 oxygen. Multiply by oxidation number of oxygen is
-2.
-2.
16.
Is equal to what?
Equal to 0.
0. Because there is no charge. Okay. Now calculate 3 plus x minus 8 equal to 0. And now x minus 5 is equal to 0. X is equal to plus 5. Okay. So now the phosphorus oxidation number is plus 5.
Mhm.
Okay, for any electrolyte solution, suppose you have. So what is actually, listen carefully my question, okay? What is actually the property of electrolyte solution? What is the property? How you can say that this is electrolyte solution? Because
Dissolved in water.
why? What is the characteristic? What is the property of electrolyte solution? What I explained in chapter 4 in the beginning.
It
What you
dissociates
mean?
in
Huh?
solution. It
Cational ion.
dissociates
Yeah,
in the
because
on solute.
it conduct electricity. You forget that I told you because of the ions. So the property of electrolyte solution is it means that it conducts electricity. That is its property. Suppose you have different, in the case of molarity or dilution in 4.4, suppose two solution you mix together. Suppose what you do, two solutions you mix together, and the question may be asked, okay, how many moles of hydrogen or proton present in this solution? Okay. All right. Suppose example I will take. Suppose we have two solution of KOH or sodium hydroxide. Suppose we will get 10 milliliter of this, and its molarity is, right, molarity of this solution is 0.350 molar, and you have this one is volume is 5 milliliter and molarity is giving here 0.520 molar. If both you mix both solution, right? So what will be the concentration or molarity of OH minus here? So what you do, you just not the sorry. Oh, wait. Not the concentration. So how many moles? So you know the formula, molarity is equal to moles per liter, and mole is equal to what? Molarity into liter. This formula you should know this. So here we change liter into milliliter into liter. So 10 multiplied by 1000, so this is 10,000 liter multiplied by 0.350, and this one 5 milliliter multiplied by 1000, so this is you will get 5000 multiplied by molarity 0.520. So whatever you get here moles, these are the moles. N is equal to what? These moles. And now this mole of OH you have, and this mole of OH you have, mole negative, you add both mole, you will get the total moles.
Doctor,
Yes.
how did you get 10,000 of liter?
Sir, milliliter change to liter, what you do?
supposed to
No, 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 no. I'm opposite. I'm opposite. Divided by 1000. Sorry. Thank you. Not multiply. So you will get 0.1201, right? 0.01 liter. Similarly here, 5. Not 5000. 0.005 liter. Then you multiply by this molarity into liter, you will get mole of OH here, and molarity into liter, you will get mole of OH here. Then you add both moles, total mole you will get it. That is your answer. Similarly, you will utilize this concept into the proton, mole of H plus. So you can also use the same concept. Now here, understand? Any question here?
I add them.
Yeah, you add both both OH. You calculated N1, N2. Total will be whatever you get.
Thank you.
Molarity I have done, oxidation reduction I have done. Now you ask any question please. 4.1, 4.2, 4.4, 4.5. I cover all 4 sections. Okay, I will ask some questions here. Okay, now yes,
The last point I couldn't understand very well.
which one? Last point? Okay, now suppose you calculate N1 of OH minus, and you get N2 number of mole from second from NaOH, that is also OH minus. This you will get from KOH, this you will get from NaOH. And now you add both, the total OH you calculate it. What is the problem here? Clear?
Yes, teacher.
Should it be two OH?
2OH? No, sir, whatever value you get it here, suppose you get here 0.652, you get this one here 0.250, then now you add 0.250 here, the total 0, 0, and this is here, 8. So now this one, the mole of both OH mole. You understand this like this, not 2 OH. I'm not saying this is 1, this is 1. If both are 1, then you will put 2 OH.
Thank you, teacher. I understand now.
Okay. All right. Now, suppose you have an example. Suppose you have calcium phosphate. This is the formula. PO4, 2, and this. So you should know that how many calcium we have? 3Ca2 plus, because this 2 belongs to calcium and this 3 belongs to phosphate. So this is calcium phosphate. So now this one, this 2 belongs to calcium, and this 3 belongs to phosphate. So you will write here calcium 2 plus phosphate 3 minus. But how many calcium you have? 3. So you have to put 3 here, right? And how many phosphate you have? 1. So this 1 already here. So now this is, no, sorry, 2. Phosphate are 2. So you will put 2 here. So now you have the 6 plus charge here and 6 minus charge here. Question is that how many charge species these compound has? Charge species, then you have to write like this: 3 mole of calcium 2 plus and 2 mole of phosphate 3 minus. These are the charge. So you should write like this. Another example you will take sodium carbonate. So sodium is 1, so the carbonate is 1 here. We cannot write anything here, 1. And this is 2 belongs to carbonate. It is just like this, Na plus CO3 2 minus. Then you will write formula Na2, because this 2 will go there and this 1 will come here. So in the bracket we will write carbonate 1. So 1 never write. So how many charge of the species you have? So you can write here 2 Na, 1 plus you have, plus 1 carbonate 2 minus you have. So here 2 plus, here 2 minus. So both are neutralized. So you have to write the charge species like this for any compound. Clear? Any question now here? So what are the charge species? What are the charge species in this compound? Question will be like this. Clear, or just you want to ask anything? Please tell me now. See, all students gone. Only 27 students left out of 40 students, 45.
No, that's clear, teacher. All you have to do
Huh?
is just to find the charge, which means 0. So you have to balance the equation in that
Yeah, so
manner.
this is, look at here. Number of atoms you should write here 3. So you put 3 here. Number of atom, how many phosphate? 2. So you put 2 here. And charge, you know that 3 minus and 2 plus. So this becomes 6 plus, this becomes 6 minus. So both are 0. Neutral. And as I told you, the ionic compound always has 0 charge. Ionic compound always have 0 charge. Now my battery is going. Okay, so now this is all about chapter 4. Any question now? Otherwise, I will stop.
Solve net equation, net ionic equation.
Pardon?
Net ionic equation.
Okay, do you have any Any question do you have with you? I will solve that. Okay,
No, I
now,
don't have actually.
so
I have
you
question,
mean,
doctor.
yes, okay, go ahead.
There is some question. He asked me to find how much water should we add. Assume
Okay, well,
volumes are.
okay, now I'm coming to that, don't worry. All right, now that is question is for dilution. Dilution formula you always use M1V1 is equal to M2V2. This is stock solution concentrated. This is dilute solution D, dilute, in which you will add water. This dilute solution concentration always less, this concentration always more, right? Number one. So now suppose you have question number one is stock solution whose concentration is suppose 50 molar. 50 molar. Okay. Question is how much volume you will take from stock solution to make 0.35 molar solution in 0.600 milliliter. Okay, this is the question suppose. So this is your stock solution. This is your stock solution. So now I will write first here M1B1. This is for stock solution. The molarity is giving, but volume we have to determine. That is, we have to determine. So I will write here 50 molar into volume we have to determine, and M2V2. M2 molarity is giving here. This is for dilute solution. I will write here 0.350 into the volume. This should be in liter. Okay, but in dilution, don't worry, don't change into liter, no problem, because both unit will be cancelled, because you have to write into milliliter. So what volume in milliliter you will get it, so no need to change. So write down here 0.600 milliliter, and this also milliliter, so no need to change it. So this you will get 0.350 times 0.600 divided by 50. Suppose you will get second volume, you will get 200 milli. Okay, now 600 liter I will put it here. 600 milliliter. Don't put point. Otherwise, calculation will be tough. 600 milliliter. So now you have calculated. Suppose 200 milliliter here. So this 200 you take from here, from 50 molar. Take 200 ml and you put into this flask. This is 200 ml. You put it into this flask. This flask capacity is 600 ml. Now 200 ml you took it from the 50 molar. How much water you added to complete this level? How much water you added now?
400.
400. Very good. So now 400 water you added, and now this solution whose concentration is 0.350 after dilution. So sometime the question may be asked how much water is added, then you calculate. Otherwise here no need to add how much water, automatically your V2 you calculate and you stop the calculation. Any question now? I think almost finished all section.
My
Go and
question then is net ionic equation.
okay, what is your question now?
Net ionic equation.
Net ionic equation. Suppose this is reaction you have solid, and this is aqueous, aqueous, aqueous. First of all, that ionic equation you have to write, ionic, then total ionic. Ionic equation you just change into ion, all ion. This is 2 belongs to this, so you will get 2 plus this Cl minus. You have to balance the charge, you multiply by 2 here because there are two chlorine here, plus K plus you have, this is K plus, but there are 2 K, so you will put 2 here, plus sulfate. This 2 belongs to this, so this is 2 minus, so the charge will be equal. When you write down the ionic, this never split. You have to write the full compound like this. You don't split into ion. This you can split into ion, K plus Cl minus. So now 2K plus and 2Cl minus, this will be equal. Total ionic ions, which is responsible to give pure product compound, this one. So which ion are present in this compound? Tell me now.
We have iron phosphate.
There is no iron here.
Not is it iron?
Lead.
Lead. Oh, okay. Sorry.
So you will write lead 2 plus plus sulfate 2 minus. This will give you this product. So these are net ionic equation. Which ions are responsible to give the solid product? That is known as net ionic equation. Clear?
Clear.
Any question which is do you have in your mind? Now I'm going to stop now because I did not take my dinner because of you guys. And now I have to correct some reports that I will sleep around 12:30. That tomorrow morning I have a session in the morning. So I have to get up in the morning.
Thank you very much, Doctor.
Thank you.
Thank you, Dr. Farah.